In his role as a principal developer advocate at Amazon Web Services, our upcoming DevOps champion has been working on storage performance measurement, tool development, and quality engineering. With his key focus areas on machine learning, data analytics, and storage, he constantly strives to simplify the intricacies of AWS cloud services to developers. Apart from hosting tech conferences on various areas, he has authored more than 50 white papers on performance benchmarking and monitoring for Hitachi and IBM. Through his talk today, he is going to help us understand on how to use AWS SAM templates to manage serverless infrastructure as code. He will also talk about the process to construct highly flexible and reusable SAM templates to manage the serverless application. It's now time to get the ball rolling. Let's all welcome Mr. Suman Debnath.
Hello everyone, welcome to this session on Magic of Serverless. In this session, we are going to discuss what serverless is and how you can make use of serverless to build modern application for your company or for your side projects. I'm Suman Debnath, a principal developer advocate here at AWS, and I'm super excited to share all of that with you today. If you have any questions during the session, please feel free to ask me. I'll be very much happy to help you. You can reach out to me over any of the social media of your choice, LinkedIn, Twitter, whatever you feel like, but do ask questions whenever you have any. Now, before we get into serverless, let's look into what a typical application architecture journey is for any software engineer. So if you are new to software development or you are just getting started, this would be a typical step that one would take or you would take. That is, you will pick up one server. Inside that, you will have everything, starting from database, code, servers, and proxy. Now, if you look at this, this is not a very good architecture. As we can see that there is a single point of failure. That means that if, let's say, one of the component goes off, the whole stack goes off. Now, what you can do over the period of time is you can segregate that from a monolith architecture to a tiered architecture, where you pass on different tasks in a different servers. Like as you can see here, we have a proxy server, we have a server for the code, and we have a server for database. You can even go further and divide that into client and backend, maybe the front end and the backend. But still, this is not that scalable. It is surely better than what we have seen a while back, where you have one server doing everything. But still, it is not that scalable. Now, what you can go from there is you can add similar servers in each of these different components. So you can have multiple load balancers, multiple clients, multiple database, multiple backend servers, so on and so forth. Now, this architecture might look pretty decent with respect to the regular tier architecture, but still we can imagine that what would be the complexity of the infrastructure that we may have to deal with over the period of time, because the more your business grows, you have to add more and more servers. Now, when we speak about servers, there are multiple things that we need to take care of. First is, what should be the size of the server, and how we can budget that, because most of the time your application may not, you cannot predict what type of workload that you may get beforehand, right? You can approximate surely, but you may not get a right notion or right view of what type of servers and how much budget that you should have. Similarly, you may need to have multiple. You may need to ask multiple questions, like how you can do the access control for all those servers. What type of failures that your application should be capable of handling, and so on. So there are hundreds of different questions that might come up when you deal with servers in your environment, whether it's a physical server or virtual machines, whatever it is. And this is the reason that when we talk to developers, we have noticed that developers spends most of the time for these kind of operational and maintenance tasks for the application, right? Rather than writing the code or solving the actual business problem. And this is where serverless comes into picture. And we are going to go deep into what serverless is. But these are the 4 different tenets or 4 different properties that makes serverless. Any service as serverless. The first being there is no server to manage. That doesn't mean that you don't need servers, but it's just like you are not managing them. So as and when you need infrastructure, if I talk about on the cloud, it will be managed by AWS, right? So you don't have to worry about the infrastructure that is getting provisioned for you in the backend. The second thing is it scales. So it scales based on your usage. So you don't have to pay when you are not using anything. It's kind of similar to most of the services that we have at AWS, but you never pay for anything idle, and the service itself scales based on your workload. So this counters that problem that we were discussing a while back, where you have to budget for the number of servers that is needed for your application. So in serverless, you don't have to do that because it will automatically scale, based on your workload on your application. And lastly, you don't have to worry about availability and fault tolerance because that is an inbuilt there are any of the service that we have within AWS, and you don't have to worry about redundancy and all of that. So all of those things are taken care on the cloud. Now, when we think about serverless, the first thing that comes to our mind is AWS Lambda. We will also see that AWS Lambda is not the only service which comes under the category of serverless, but this is the first service that you will think of when we talk about serverless on AWS. Now, AWS Lambda sits, in the middle of different paradigm of computing. You can think of it as a function as a service, or a FAS, or an event-driven computing, and that is the most important part. So it's not like an empirical. It doesn't work like in a traditional manner that how a software or a code is executed. Like when you write a code, it executes one by one in an empirical format. But in Lambda, what happens is it's kind of an event-driven architecture. What that means is whenever there is some event, your Lambda function will kick in and it will do its task. And once the task is over, it will the infrastructure in the backend will get destroyed, right? So, and that's why you don't have to pay when your application is it's not being used by your customers. So this is what we are going to talk about today, like how this event-driven architecture works. So imagine that you have a function, and this function, all you have to define is what is the runtime of that function, whether it's Python, Node.js, Java, Golang, .NET, and even containers. We started to support, I guess, since last year. So what that means is all you have to tell Lambda is, hey, this is my application, and my application is written in a Python. That's all. So in the back end, Lambda will create a container for you, and it will load your code, and it will execute that code in that container. And once that operation is over, it will just destroy that infrastructure. Now, when your Lambda function will get triggered, it will be based on some of the event sources. Like it can be a change of resource state, or a request to an endpoint, or a change in the data state. For example, let's say you may want to trigger a Lambda function when there is an entry to your DynamoDB table or in a database, or it can be triggered whenever there is an image upload into S3 bucket. And once your Lambda function is executed, it can do the execution of the task, and once the task is over, it can send that output, or whatever is the business logic that you have written in as a Lambda function, to the downstream services. It can be within AWS or outside AWS. Now, this is how a Lambda function typically looks like. So this is an example of Python, but the same story, the definition remains the same for any of the other runtime. So you will have one function called handler function, and this function takes 2 arguments, and this is the function which gets triggered whenever there is an event from whenever there is an trigger from an event. And there are 2 arguments to this. One is event object, and this is the object which contains all the details about that particular event. So this event can be, let's say, if it is an API gateway trigger, then it will have all the details about that HTTP request. If it is if the trigger is, let's say, object upload to S3 bucket, this event object will contain all the details about that S3 object, and we are going to see that in the demo in a while. And the other object or the other parameter that this function has is a context, and this is kind of this saves, or this contains all the metadata information about the runtime, which you may not need always, but if you want to know what is the request ID, in what log group it belongs to and all of that, you can check this context object, and you can see what are the things that you can get in the context object. But basically this is the Lambda function. You have a Lambda function which gets triggered whenever there is an event, and it contains two objects. One is event object and the context object, where event object contains all the details about the event, and the context object contains the metadata information of that event. So with that, let's go to the console and see it all in action. All right, so as you can see, I have already logged into my AWS account, and what I can do is I can simply search for Lambda. So you can type here, or you can come to the recently visited. If you have visited that service, you can get to the service here, or you can also come to all services and you can click on Lambda. So I've already opened this in a different tab, so we can go ahead and create a Lambda function. So the function that we are going to create, or the application that we are going to build now, is going to do this. So we are going to write some text in a text file, and we will upload that file in an S3 bucket. And when we upload that file in an S3 bucket, that will trigger this Lambda function, which will read that file, and it will use one of the machine learning service that we have called comprehend, and it will do some analysis on that text. Like it will try to predict what is the sentiment of the text and so on and so forth. Okay, and we are going to see that in action. So first thing that we need to do is we have to give some function name. So let's give some function name, that my first function. We need to define the runtime, so this is going to be Python 3.8, and we can simply click on create function. As we can see, the function got created, but it doesn't have any trigger because we have not added yet. So we are going to add the trigger as S3. So let's go ahead and do that. So let's select S3, and here we have to define in which bucket it should monitor, meaning that this Lambda function should be triggered only when there is a upload of an object in a particular bucket, right? So otherwise it will not understand when I should get executed. So I've already created one bucket called DevOps Summit 2021, and we are going to use that for this demo. And all we have to do is we can come down and acknowledge this and click on add. Now we have added the trigger. That means that now if I upload any file in that S3 bucket, this Lambda function called my first function should get triggered. But we have not written the code which will do that text analysis, right? So this is what we are going to do it now. So this is the Lambda function, and all we have to do is we have to paste write our own code. So I have already written this, and I've just copy pasted here, but it's pretty simple. We are going to use Boto3. So Boto3 is the SDK that we use to write or to use any resource of within AWS using Python 3. So we do have SDKs for different language, but Boto3 is the SDK for Python. So as we have discussed, this is the Lambda function that we always have for any Lambda function, and it has a trigger and a context. Now what we are doing here is we are creating an S3 object and a comprehend object, because this is the service that we are going to use to do sentiment analysis on the text, right? So as we just learned, that event object contains all the details about the event, and here the event is an object upload into the S3 bucket, right? So what we are doing here is we are just reading the file name and the bucket name from this event, and we are then downloading that file using this get object method, S3 get object method. And once that is there, then we are just calling comprehend to do sentiment analysis, right? So the way that we can do this is simply saying comprehend dot detect sentiment and the text, and this text object we have already read from our S3 object, right? And once that is done, we are just printing it into the console. But this is where the fun part comes for Lambda. Once you are done with your task, like in this case, I'm done with detecting the sentiment. Now you can make use of this output to any of your downstream tasks. So you can send it to some which can trigger another Lambda function, or you can save it to some database, or so on and so forth. So in this example, we are going to just print it in our console. Similarly, we are also calling some other methods like detect entities and detect key phrases, and all of these comes as a part of comprehend service itself. So once we have written our code, what we can do is we can simply save this, and we can deploy this. So now our function has been deployed. But one thing to note here is here the Lambda function need to access comprehend service and also S3. Right, so these are the two permissions which Lambda would need while executing this code. So for this reason, we need to give proper access to this Lambda function. And the way that we can do this is we have to first go to configuration and come to permission. And this is the default role which got created at the time of creating this function. What we can do is we can just open this, and we can add the policy for comprehend and S3 so that it can talk to both of these services, right? So by default, it comes with a basic execution role which contains things like reading or writing logs to CloudWatch. Okay, so now what we can do is we can click on attach policies, and we can search for comprehend, and we can select comprehend full access, and also we can give S3 full access. Although full access is not needed, just read access would be good enough, but it's just a demo, so we can live with that. So once you attach this, now your Lambda function has the execution permission to access the service for S3 as well as comprehend. So now we are all ready to make a trigger. So to do the trigger, we need to go to S3 bucket, right? So let's open S3, and let's search for the bucket which we have selected for trigger. As we can see, there is no object here, no files inside this bucket. So let's go ahead and upload one object. So I have one object called a test file. So let's drag and drop. And upload this object. So the object upload is now successful, right? So before we go ahead and see if the Lambda function got triggered or not, I want to show you what this text file contains, right? So this text file contains just one line of a statement. I think it's very small to read, but it just says that I was reading this book called Data Science on AWS by Chris and Anshia in the weekend, and I just love it. Right, so it's kind of a positive feedback about this book. So let's see what comprehend detects. So for that, let's go back to the Lambda function and come to monitor, and we can click on CloudWatch. So CloudWatch, it's getting opened here in a different tab. So as we can see, we see one trigger, and if you open this, we can see that it has identified that this contains the statement or the text file contains positive sentiment with some sentiment score or the confidence value, and also it has detected a few of the entities, like it has predicted that data science on AWS is a title, right? So as you can see that we are making use of machine learning within our application without any machine learning knowledge or expertise. And similarly, we have also defined to print key phrases, and as you can see, it has identified this book as a key phrase, right? So as we have just seen that it is very simple to get started with serverless using Lambda through the UI, but we have done a lot, right? So if you look back, we have to add the permission manually, then we had to write the code here, and it is not a very good practice to write the code in the console. And also, in this case, we have not used any external libraries, but if you have to use any external libraries, you have to package that together. So there are a lot of rough work needed when you do this manually. So next, we are going to see how we can automate all of this and build a serverless application using some framework. So let's go back to the presentation and see how we can do that. All right. So now that we have learned how you can make use of a UI to create your first Lambda function, and we have also learned that what are the challenges that you might see when you write a production grade Lambda function where you have a lot of different dependencies in your application code, or your Lambda function is talking to various other services where you have to manage the access control policies and so on. It's not that scalable, and it's not that it's not a very good practice to do it all through UI. So there has to be some good way, because you don't want to make your hand dirty doing all those manual tasks. So with that, we are going to introduce ourselves with a framework called SAM, or Serverless Application Model. So this is one of the framework that we have from AWS, which you can make use of to build an serverless application using your code. So it's kind of an infrastructure as a code for serverless application. There are many different frameworks like this there in the market, and feel free to choose the one that suits the best for your team. But selecting the right tool is less important than selecting a tool, right? So we should always make use of any of these frameworks. So today we are going to talk about SAM, and SAM comes in two parts. One is the SAM template, and the other one is SAM CLI. So what SAM template is, it's kind of a, it's just a YAML file where you just define what are the resources that you need for your application. And in the back end, serverless, AWS will create all of those resources for you on your behalf. So there is kind of a infrastructure as a code you can think of. And the other part is the SAM CLI, and this is the tool that you can use to build or deploy your serverless application from the CLI. Okay, and we are going to see that in the demo section. So just to give you an intuition of how this serverless SAM template looks like, this is a typical format of a SAM template. And again, we are going to see this in the demo section in a minute, but you can see that in just 21 lines of code, we are creating a lot of resources. So in this example, we are creating a Lambda function, we are creating an API gateway, we are creating an IAM role, and a DynamoDB table, right? So imagine that you have to do this all manually or through some other CLI tools or any of the automation framework. It would have been not less than 200 lines of code, right? So this is the beauty of SAM. And now what we are going to do is we are going to jump into the demo where we are going to build a bookstore app where we are going to use API gateway, Lambda function, and DynamoDB. And it's a very simple hello world kind of an application where you can update the data database for your library or your bookstore, where you will have, let's say, the book author name or a book title name, and maybe the number of pages of the book, and so on and so forth. And all of that data will be stored in a backend database, and in this case we are going to use a DynamoDB table for this. And we will also create some of the methods using API gateway, like we can update the table, we can delete a particular book from the table, and so on and so forth. Okay, so with that, let's jump into the demo, and we will see that how easily we can make use of SAM to deploy this particular application where we are using multiple services. All right, so with that, let's open our console. And for this demo, we are going to use a Cloud9 instance. So if you are new to Cloud9, Cloud9 is an service from AWS where you can make use of Cloud9 for your development work, which gives you a nice IDE, as you can see here on the cloud. So all this code is given to you in the presentation slides. If you have seen, there is a QR code, and this is the GitHub repository that contains both the apps. The first app which we have used, which we have created a while back using Comprehend, and the book library app is something that we are going to do now. Okay, so let's go back to our Cloud9 instance, and if you see here, we already have this folder called book lib app, so we can go inside that. And I've already created the application using SAM. So the first thing that you would typically do is you will write SAM init. Okay, and then you start creating or initializing the application. But since I've already done that, I'm not going to do this. And when you do this, after you run SAM init, it will ask you a few of the questions like what should be the name of the stack and so on, and then it will create a folder structure like this, which will contain events, tests, and so on. So the first thing that we need to edit is the SAM template, which we have just briefly seen in the presentation. And at a high level, it contains a couple of sections. So the first two lines tells AWS that this is a SAM template, because under the hood, what SAM uses is it uses cloud formation, so which is another service that we have, which is not only for serverless but for everything within AWS. So it's kind of a service for which is used for infrastructure as a code, not only for serverless based application but for anything in general. So what SAM does is basically, when you try to deploy an application, all these resources or this template gets converted into a CloudFormation template. And how AWS know that this particular template is a SAM template or a CloudFormation template? So this is, these are the two lines which tells AWS that this is a SAM template, and you need to convert it to the CloudFormation template. Okay, and then we have the description, which is just a comment, or you can write any text which defines your application. And then we have a global section, which I'll come back after a moment. But let's go into resources. So this is the section which contains all the resources that we need to create for our application, right? So I have created a couple of resources. So first resource is, if you remember the architecture diagram, if I just have to go back here, we need to create an API gateway, obviously a Lambda function, DynamoDB table, and IAM roles, right? These are the 4 services we are going to use. So if you now come back to this code, this is the DynamoDB table that I'm creating, and the type is a simple table, and you can refer to the documentation to see what are the different types of resources that are supported within serverless. And we can define a few of the properties for this table. Like in this case, I'm defining the book name or ISBN ID as the primary key for this particular table. And here we are defining the Lambda function, right? And in this Lambda function, we are going to use API gateway in front, so that we can create our get, post, or delete methods and so on. But before that, we need to mention where is my actual code is lying. So that is where we are defining the properties of this Lambda function, which contains a variable called, or a parameter called code URI, and it says that the code is inside this folder books_lib_app. So if you see here, we have this folder, and inside this we have our application called app.py. Okay, and as you can see here, we have this application app.py, and inside this, if I just double click inside this, I will walk you through this code, but inside this we have a Lambda function called Lambda handler, and that is what it's mentioned here. See, the handler is app.lambda handler. So far we have created 2 resources. One is the DynamoDB table, and another is the Lambda function. Now the other resource that we need to create is the API gateway. Now this is the best part using of SAM. You don't have to create a API gateway separately, just like how we did for the DynamoDB table or the Lambda function. But what we can do is we can just simply say that what should be the trigger for this Lambda function. So we know that this API gateway should be the trigger. So what we have done is we have just added a couple of triggers. One is the API, one is add book, another is list book, and another is delete book, right? And we have defined that the type of this trigger is API gateway, right, or API. So now what it will do automatically is it will create an API gateway for us. It will automatically create the API gateway resources that is needed for us. Okay, and we can define the path, and we can define the methods. That's all, right? And since we need to have some grant some access, because it is going to read write data from the DynamoDB table, so that's why we are just defining some policy for to access the DynamoDB table, right? That's all about the YAML template. So this is the this is all you have to do to create all the resources that we need for our application. So let me close this, and don't want to save this because it's already there. So now this is the application, right? So the application might look very simple now. We are using some external libraries like simple JSON. So we need to create a requirement.txt file, which we have already created, and we have defined that simple.json there. And now if you look at this application, it's very straightforward. We are creating a DynamoDB object, and we are defining the table underscore name. And one thing I just missed out is in the template that I forgot to explain the global thing. So in global, so let's say you are in your YAML template, you have 10-15 functions, and you need to define like all the functions should be of Python 3.8, or maybe you want to define the runtime as let's say 300 seconds. So in spite of doing all of that, multiple times for all the Lambda functions, you can define it all in one section under globals. So that gets replicated across all the functions that you create in your YAML template file, right? And that is what we have done. So although we just have one Lambda function, but still just wanted to show you what is the use of Lambda. And here we are defining environment variable called books underscore table. So because this DynamoDB table will be created dynamically by the Lambda function, and that's why not the Lambda function. This table will be dynamically created by SAM. So we need to access that table name. So that's what we are saving it in books underscore table. And now if you come back to the application, we are just reading that books underscore table variable from our environmental variable. Okay, so now what we are doing, since we have only 3 functions, that's why we see only 3 methods. One is the get, another is the post, another is delete. And what we are doing is we first check what is the event type. So whether it's an because we need to make sure that it is an HTTP based method, and that is what we are checking here. And once it is known that it is a get type, we will just go through this code where we will just read the table, DynamoDB table, and send the data back to the user, right? So in the get method, we have created 2 different options for the users. One is if the book ID is given, then we will provide exactly that book if it is there inside the database. And if the book ID is not there, if not mentioned by the user, then I will do a full scan of the table. Okay, and this we are going to see when we trigger this using our postman, okay, using this API gateway. Similarly, we have a post method, and if I just expand this post method, it's very simple. We are just reading the data from the body section of the event, and then we will just iterate through all the items in the body. So because it might happen that user is putting multiple entries for the database, right? So we will just iterate over all the items in the data, and we will call this method put item and insert the data into the DynamoDB table. And similarly, we have a delete method where we expect users to give an object ID, or rather the book ID, and based on that book ID, we will just delete that respective book from our inventory. Okay, so let's go ahead and deploy our Lambda function. So the way that you can do this is, first you have to run SAM build. So the first thing that you need to do after creating a SAM serverless application using SAM init is SAM build. So it will build the whole application for you, and once that is done, you can do SAM deploy. So when you do this for the first time, you might have to do SAM deploy -g or guided, because this will ask you a few of the questions regarding your application, and once that is done, it will save all of your the input that you provide in the CLI into a TOML file, as you can see here, which it will read when you try to deploy that function next time. So if you see here, I have not run with a -g option. I've just executed as SAM deploy, right? So since I had this file, it just read all the inputs from this file. So let's wait for this application to get deployed. All right, now that we see our application has been deployed successfully, what we can do is we can go to Lambda and we can refresh, and we can see that our bookstore booklib app is up and running. And what we can do is we can simply click on API gateway, and we can see that it has already created the API gateway. And what we can do is we can simply copy this URL and open Postman. And we can just simply give the URL here and send. So let's see what it returns. As expected, it returns an empty list because there is no data in the DynamoDB database, right, or DynamoDB table. So now first thing that we have to do is we have to put some data. So let's go ahead and put some data using the post method. So let's enter the URL, and in the body we can send some list of books with a book title, the ID, number of pages, and author. So let's send it, and you can see that we got the message as books data updated, because this is the message that we have written in our code to return. So let's go back to the get method and try to send the get method again. So now you can see that it is able to fetch the data from the backend DynamoDB table, right? So now what else we can do is we can also define a particular book. So let's say I want to get the details of this particular book, right? Data science on AWS. So I can give this as a key value pair as a parameter and send it, and surely we are seeing the output as the details of that particular book, right? Now the last thing that I want to show you is how we can delete a particular book. We have this delete method, and we have to do is we have to just copy this URL and paste it, and we can again define some book which we want to delete. So let's say I want to delete this book, right? So let's give this book ID and the the key value as ISBN ID, right? And let's send it. And as the message says, the book has been deleted, right, successfully. So let's go ahead and try to execute the get command, and we can see that that book got deleted and we don't see that book, right? So as we have seen, it's very simple to integrate multiple services and deploy a serverless based application using SAM CLI and SAM tool, SAM framework. And you don't have to worry about permission, packaging, and so on and so forth. So that's about it. I hope you have learned a little bit about serverless today. And if you have any questions regarding this session or anything in general around serverless and AWS, feel free to send me a note. I'll be very happy to help you. Thank you so much for your time. I hope you have a great day ahead. Thank you.